Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now I am going to explain the chapter Carbon and its Compound for class 10 according to CBSE syllabus. Now here the topic is nature of covalent bonds and allotropes of carbon. This is part 11 where I am going to explain nature of covalent compound and covalent bond and allotropes of carbon. First we will say what is meant by nature of covalent bond. First the question is what is meant by covalent bond. Covalent bond is the relation between two atoms that having a strong attraction between two by what? By sharing of electrons. If sharing of electron takes place, one bond is formed, the attraction between atoms form, that is called covalent bond. But question is who will give the covalent bond? Side by side one ionic bond is there. What is ionic bond? Where the one atom give electron to other and other atom is ready to take that electron towards it. That means one can lose electron, one can gain electron. If possible, then only ionic bond form, whereas covalent bond form by sharing of electrons takes place. Why only covalent bond takes place between this type of atoms and why this ionic bond is formed in the other type of atoms? What is the cause behind it? Actually we know every atom has a tendency to attain inert gas configuration. By what method? By either gaining or losing electron, gaining and losing electron, or by sharing electron. Ionic bond we leave now. We will go to covalent bond because this is carbon and its compounds chapter. So covalent bond is formed by sharing of electron. That means suppose A has one electron and B has also one electron. After some time both electron will share each other. For A when it is counted, that means these two electron. When B configuration, when you will count, you will take here this electron for both electrons, counting for both A and B. That means where A is counting, that means this electron counting towards A. When B is counted, the electrons is counted for these two electrons for B. But question is already I have explained the electron, that is called electron dot structure. I have already explained different electron dot structure in different type of covalent molecule, just like hydrochloric acid, hydrogen, chlorine, ammonia, water, methane, ethane, ethine, ethene. So many molecules are there where sharing of electrons, only covalent bonds are there. Let us simply methane. You know methane, that means here four hydrogen attached to carbon by covalent bond. Now it is a covalent bond. This is also covalent. That means sharing of electron takes place. Carbon and hydrogen, this carbon hydrogen, this carbon hydrogen and this carbon hydrogen. That means sharing of electron takes place means covalent bond produce. Electron taking and losing electron receiving or gain electron and losing electron, that is ionic bond. Later in a metallic chapter, metals chapter will see what is mean ionic bond and ionic compounds. Now you should know what is meant by covalent compound. Already I have explained electron dot structure, and here due to sharing of electron, here very weak intermolecular force of attraction there is no strong force of attraction. See, if there is a strong force of attraction, this is very difficult to break the bond, but if it is a weak attraction, it is very easy to break the bond. To break the bond means automatically very easy to break the weak intermolecular force of attraction. That is why they are soft, solid, liquid and gas. You can find chlorine is a gas, bromine is a liquid and iodine is a solid. They all are that is having covalent bonds and they are covalent compounds. So due to weak intermolecular force of attraction, the covalent bond can easily break. That is why they are very soft, solid, liquid and gas. Next is no charge particles. Why no charge particles? Because there is no taking and losing electron takes place. There is no gain of electron. There is no losing electron. That is why there is to be charge. There is no charge because it is only sharing of electron takes place. One electron and other electron both are sharing between two atoms. That is why there is no positive charge, no negative charge. That is here poor conductor of electricity. Conductor of electricity means there should be strong positive charge, strong negative charge, then only it will conduct electricity very well. But since it is no charge particles formed during sharing of electrons, that is why they are very poor conductors of electricity. Insoluble in water. Insoluble in water, since it is a covalent compound containing covalent bonds, that is why it never be soluble in it never soluble in water, because water where H plus OH minus are there. If they are ionic compounds, it should be soluble because ionic compound contain positive negative charge, but whereas organic compounds that are covalent compounds that having covalent bonds, they are insoluble in water because they have no positive negative charge, no charge, no positive negative ion. That is why they are insoluble in water but soluble in organic solvent. What are the organic solvent? Benzene, if you say benzene, alcohol, and here petrol, ether, kerosene oil, all are called that is organic solvent. So organic compounds soluble in organic solvent, covalent compounds soluble in organic solvent, or you can say covalent compounds that mean having covalent bonds are soluble in organic solvent. What is organic solvent? Example I told: petrol, ether, that kerosene oil, benzene, alcohol. These all are called organic solvent. I hope it is clear the nature of covalent bond. The nature of covalent bond means there is no positive negative charge, poor conductor of electricity, they are liquid, solid and sub-solid, and weak intermolecular force of attraction, insoluble in water because there is no positive negative ions are present here, soluble in organic solvents such as here alcohol, kerosene oil, petrol, and also your ether. So I hope nature of covalent bond is clear. Then I will proceed to what is meant by allotropes of carbon. You know graphite, you know diamond. Then what is the difference between graphite and diamond? What is called allotropes of carbon? We will see now. Now next topic is allotropes of carbon. What is allotropes of carbon? You know carbon has also the characteristics of diamond. Carbon also has the characteristic of graphite. Then what is difference between graphite and diamond? Diamond is so costly and graphite is not so costly. That means here if a carbon can exist graphite and diamond and Fullerenes, and what is meant by here allotropy. An element exists in two or more forms here having different physical properties and but identical chemical properties. Remember, element exists in two or more forms, different physical properties but identical chemical properties, that is called allotropes. And very simple example, carbon. Carbon having allotropes. And what is allotropic forms? The different forms which is existing in nature, that is called allotropic forms of an particular element. Now carbon, very important, carbon has three allotropic forms: diamond, graphite and Fullerenes. Now diamond, you remember also, you know also, diamond is very useful and very costly and very precious also. And what is diamond? Each carbon atom bonded to 4 carbon atoms, one middle carbon atoms, and here one, and here one, 3, 4. That means 4 carbon atoms here joined to a particular carbon. Similarly, other carbon atom also joined to particular 4 carbon atoms. Similarly, everywhere they so compact so compact and so close, and that gives a diamond, three-dimensional rigid structure. Three-dimensional rigid structure means it is very hard. It is a hardest substance. That means each carbon atom attached to 4 carbon atoms and having three-dimensional structure of rigid one. That occurs in nature. Diamond always occurs in nature, and it is also synthesized. What is mean synthesized? Synthesized means man made. Man also try to making the diamonds. It is successful, so it is synthesized by pure carbon and have to high pressure and high temperature. At a particular condition, the carbon changes to diamond, that is called synthesized diamond. And original diamond, that is a natural one, it comes from the nature. And now synthetic diamonds are very small size. What you are preparing or what you synthesize the diamonds in lab or in the industry, then what happens? These are very small size, but looking, behavior, nature, tendency, all the things are similar to natural diamond. Natural diamond, what is the color, what is the structure, and all are similar, but synthetic diamonds are very small size. I hope it is clear what is diamond. Diamond means one atom attached to 4 atoms by rigid structure, three-dimensional structure. That is why it is hardest one, and here it is occur in nature. It can also synthesize by man, but it is very small in size and up to high temperature and pressure. The carbon, pure carbon, change to synthetic diamond. So next we will say what is meant by graphite, then what is difference between diamond and graphite. Then come to graphite. What is graphite? Graphite, you know, very soft one. It is black color, very soft one. It is used for sharp pencil. Now graphite, each carbon atom is bonded to 3 carbon atoms. You know, carbon has 4 valency, that should be satisfied by any atom or group of atoms. But here you know there are 3 bonds, that means there should be 1 double bond, otherwise the valency of carbon cannot be satisfied. In the same plane, there one carbon is joined to 3 carbons in the same plane, and the structure is hexagonal array. It looks like hexagonal array because one carbon atom joined to 3 carbon atoms. Here one bond should be double bond, because here how can it satisfy their carbon valency? 4 valency of carbon cannot be satisfied until there should be one double bond. Now come to hexagonal arrays. That placed in what way? They are placed in layers, one like this and other one like this, one above other, that is placed. That means hexagonal arrays placed one above the other looks like layer structure. And here these are the main properties of graphite, where graphite is the hexagonal array structure and they are belonging to 1 carbon attached to 3 carbons, and that is why there should be 1 double bond. Then what is difference between the graphite and diamond? You know, diamond is very hard one, it is a rigid one, 3-dimensional structure, whereas graphite is very soft one. It is hexagonal array, one layer by layer structure. Then here diamond is the hardest. And what is the use? Solid lubricant for heavy machine. Where heavy machines are there, then here it is a solid lubricant, very important. Graphite is a soft solid, where they use for pencil, other one. Now bad conductor, where that diamond is a very bad conductor of electricity, very important, and whereas graphite is a good conductor of electricity. And here for making of electrodes also required. In battery, you know, there are 2 parts, one is positive electrode, negative electrodes are there. There is cathode and anode are there, and that is very important. Here electrodes are formed by the graphite one. Now 3-dimensional rigid structure diamond and graphite is hexagonal array, one above the other layer structure for the graphite, and very important, one is very solid graphite and second one is good conductor of electricity used for the making electrodes. And these are the main difference between diamond and graphite. Then I will draw the structure of the graphite and diamond. Structure of diamond. I told here one carbon is attached to 4 carbons. See, one carbon attached to 4 carbons. Everywhere you can observe one carbon is attached to 4 carbons and form a 3-dimensional rigid structure, that is diamond. Whereas graphite is hexagonal array. One hexagonal array is placed above the other hexagonal array and behave as like a layer structure. And here you can observe one carbon atom is attached to 3 carbon atoms. Everywhere you check here, they are attached to 3 carbon atoms, and that is why here the bond is not satisfied, and here you should see that is one bond should be double bond, but here not is shown, only that hexa array structure is explained and layer structure is formed and carbon is attached to 3 other carbons. Now here these are the two type of structure. One is diamond, other is graphite. And graphite is where that layer structure, it is known as layer structure, and here very soft, it is very soft and it is very rigid. And now here Fullerenes. Fullerenes here, that carbon, just like graphite, diamond, that new allotropic form, that is called Fullerenes. Here what happened, the carbon 60, first one is carbon 60, and here where it is arranged, other atoms are arranged in the shape of football. Remember C60, that where here it is called Fullerenes, where the carbon atoms are arranged in a sphere, it looks like a football, and that is called geodesic dome. Geodesic dome just means it looks like a football, and in USA that name is geodesic dome. And here designed by architect from US architect here, that is Buckminster Fuller. Here he discovered this point, that it looks like a football shaped structure, it looks like a geodesic dome structure. That is why according to that name Buckminster Fuller, the name is Fullerenes. Again see, Fullerenes means carbon 60. Here carbons are arranged in a football, like football, and that is also called geodesic dome, and that is designed by the architect. Designed by the architect, that is Buckminster Fuller. So it is called Fullerenes. So remember, he is not a scientist, he is an architect. According to him, this shape of football is known and shape of geodesic dome is known, and that is why it is called Fullerenes. I hope what is meant by graphite, what is meant by diamond, and difference between graphite, diamond clear. Then come to Fullerenes also clear. And here what is the covalent bond? Covalent bond, the nature of covalent bond, properties of covalent bond, I hope it is clear. Then we will proceed to others. That means here what is meant by, I hope it is clear to you, and thanks for watching my video. Thank you all.